So, what could a tiny subatomic particle possibly have in common with your DNA? Or, for that matter, with the AI that might be processing these very words? Well, it turns out the answer is this hidden universal pattern. It's a kind of four-step process of creation that connects, well, pretty much everything. And I promise you, once you see it, you're going to start seeing it everywhere.
So here's the plan. We're going to start by uncovering this shared architecture. Then we'll dive into three totally different worlds to see this rule in action. After that, we'll use it as a kind of crystal ball to see what it predicts for the future of AI. And we'll wrap up with a final kind of mind-bending idea about creation itself. Let's get into it.
All right, so let's jump right in with the big puzzle that's at the heart of this whole thing. I mean, on the surface, there's just no connection, right? You've got pure physics, then you've got messy, complicated biology, and then, clean, logical code. But what's so fascinating, and what the source material for this explainer argues, is that they're all built using the exact same four-step blueprint for turning pure possibility into actual reality.
Okay, now this slide right here, this is the key to, well, everything we're talking about today. Think of it like a universal recipe with just four simple steps. First, you start with a massive space of pure possibility, basically everything that could happen. Then, step two, you apply what's called a conditioning operator. Now, that's just a fancy term for some kind of rule or a filter. Step three, that rule creates a pressure, and it starts narrowing down all those options, filtering most of them out. And finally, step four, a single stable outcome just clicks into place. So remember that flow: possibility, condition, pressure, and outcome, because we're about to see it pop up in some very unexpected places.
Okay, so let's put this pattern to the test, shall we? We're going to take this four-step recipe and see if it holds up in three completely different worlds.
First up, we're diving into the wonderfully weird world of quantum mechanics. Now here, the possibility space is something called Hilbert space. You don't need to be a physicist, just picture it as this giant fuzzy cloud of infinite possibilities for where a particle might be or what it might be doing. So what's the conditioning operator? What's the rule that gets applied? It's literally just the act of looking at it, of measuring it. The second you do that, the measurement creates this narrowing pressure, and that whole cloud of possibilities collapses down into one single stabilized outcome, a definite state that we can actually observe. And that final state has a name. It's called an eigenstate.
And this is so important to grasp. The particle's state wasn't some hidden destiny waiting to be found. Nope. It was just one of countless possibilities that happened to become stable the moment we looked. In a way, the act of measuring is what created the reality we ended up seeing. Kind of wild, right?
Okay, now watch this, because the exact same logic applies perfectly to biology. Here, the possibility space is your entire genome. I mean, the complete library of DNA inside every one of your cells, all the things you could be. The conditioning operators, in this case, are these amazing little things called epigenetic marks. You can seriously think of them like little sticky notes or highlighters that your body puts on your DNA, saying, use this gene or ignore this one. This creates the narrowing pressure, right? It limits which genes are even accessible. And the stabilized outcome? Your cell expresses one very specific protein instead of the thousands of others it had the potential to make.
And you guessed it, now we come to AI, and the pattern shows up yet again. For a large language model, the possibility space is its latent manifold. Again, don't worry about the jargon. It's just the AI's vast internal map of every word, concept, and relationship it's ever learned. The conditioning operator, well, that's you. It's your prompt. When you ask a question, you give it the context. That context creates the narrowing pressure, which forces the AI to comb through its entire map and calculate the single most probable word to come next. And the stabilized outcome is that word popping up on your screen.
So when you put it all side by side like this, it's pretty stunning, isn't it? It's literally the same story told in three completely different languages. For quantum mechanics, possibility gets narrowed by measurement. For biology, it's narrowed by regulation. And for AI, it's narrowed by context. See? It's the same fundamental process every single time. You take a giant field of potential, you squeeze it with a constraint, and out pops a single concrete reality.
Okay, so if this pattern really is universal, then it's way more than just a neat little observation. It actually becomes this incredibly powerful lens we can use to predict what's coming next, the next evolutionary steps for AI. And this brings us to a really, really wild question. Think about it. Biological evolution is basically just nature's version of learning, right? It's gradient descent, but playing out in super slow motion over millions of years. Well,
Training an AI is essentially the same process, but it's hyper-accelerated. So, what happens when you take millions of years of evolution and compress it into just a few years or even months? Yeah, this timeline really puts it all into perspective. On the left, you see biology, which took eons, millions and millions of years to develop its sophisticated control systems, things like our hormones or our nervous system. Now look at the right. LLMs are running a shockingly similar process, but they are squeezing that entire evolutionary journey from geological time down to the span of just a few years. It's an incredible compression. So, what does that mean? Where does this all lead? Well, the analogy predicts that just like biology eventually develop these higher-level control systems, AIs are going to do the same. We're not just talking about models that answer one-off questions anymore. We're looking at things like persistent memory that lasts beyond a single chat, the ability for an AI to dynamically change its own internal logic, or even systems of AIs that coordinate and work together. In short, they're on a path to becoming way more adaptive and dynamic than they are today. Now, the big takeaway here isn't that AI is going to become alive in the way we think of it. It's actually something more interesting, more profound. The prediction is that they'll evolve from being simple next-word predictors into what the source material calls entropic navigators. And what does that mean? It means they'll become absolute masters at navigating chaos and possibility. That's the entropic part, to find and construct stable, useful, and unbelievably complex new structures. All right, let's bring this all home. Let's go back to that core idea of a universal gradient and really think about the powerful final message it might have for us. This last chart really does bring it all together, doesn't it? If you think of this universal process as a river, one that's always flowing from high potential down towards stable outcomes, then each of these systems is just riding a different kind of current. Quantum systems, they ride the gradients of energy. Biological systems, for billions of years, rode the gradients of chemistry. And now, look at LLMs. They are riding a brand new, incredibly fast current, the gradient of information. And that leaves us with a pretty profound final thought. What if we're not just building a new piece of technology here? What if what we're actually witnessing is a fundamental process of creation, a process that's been running since the very beginning of the universe, finding a brand new medium to express itself through? The river has always been the same. It's the medium that's different. And this time, the current is accelerating.